Okay, this is now the fourth and final example. Okay, so fundamentally we are still working with equations, right? And when we do any equations, we want our variables to be on one side of the equation, preferably the left hand side. So our first step is to get this base with its exponent to the left, and we do that by saying 2 exponent x plus 3 minus 2 exponent x equals 28, right? So just like we had in example 3, okay, in example 3 we needed to indicate where was the base that is important, and in our case the important bases here happen to be both of them because they both carry our exponent. Alright, and so now the question is, how do we isolate the 2 exponent x with that exponent, right? And one way of isolating that is by factorizing it so that we have it sort of on its own. Okay, and so we now need to go ahead and separate this so that we can take out a common factor. Okay, so if you recall from the laws of exponents, if you have the same base, so am multiplied by an, that will give you the base and the addition of those exponents. Okay, but the opposite is also true. When you have base a raised to exponents m plus n, you can write that out as a exponent m multiplied by a exponent n, and that is what we are going to do here, right? So I'm going to leave this on here so that you can see it. So we are going to say 2 exponent x multiplied by 2 exponent 3, okay, because that will still give us 2 exponent x plus 3, and then we leave this one alone. This is 2 exponent x multiplied by 1, all equal to 28. Now at this point I want to get this guy alone, so I'm going to remove it as a common factor. So we say 2 exponent x, and then what's left is 2 exponent 3 minus 1 equals 28. At this point we have something very similar to example 2, where we had the thing we care about multiplied by some number. So here is what we care about, multiplied by some number, and we just need to go ahead and divide by the number that. Okay, so we got 2 exponent x multiplied by 7. I'm going to write it down here that we divide both sides by 7 without writing out that extra step. So that means I'm left with 2 exponent x equal to 4. Okay, and now we do our b and e, we get our bases the same, and then we focus on our exponents. So 4 can be written as 2 squared, right? And now at this point we can see that x is equal to 2. Okay, now of course I want to be sure that this is right, so I'm going to go ahead and substitute on the left hand side. So I'm saying 2 exponent 2 plus 3, 32. Keep that answer in mind. I need to get that same answer on the right hand side. So I go 2 exponent 2 plus 28, 32 again. So my left hand side and my right hand side are equal, and that means that our answer that we got here is correct.